Alright, well now it's time for episode 4 of the Roomba Jailbreak. We completed most of the mechanical reassembly afterwards. The parts that we did not put back on, this bottom plate that holds the battery in, the battery itself, and this little triple pronged agitator. Those are going on last, and we need to do some electrical work before we can do that. So we've decided where we're going to mount the actual rev control hub, and we're just doing that with like a little command poster strip. So this is just like a little Velcro connection. Shouldn't be that hard to do, but it's giving me a little trouble. And there we go. So that'll be sturdy enough for our purposes. We're going to need to add a custom control circuit that we'll discuss in a second, and we're going to need to talk about a new electronics component. So let's start talking about this new component. We are talking about a DC solenoid actuated relay. So let me grab an example. I just realized I forgot to grab it. But this is what a DC 12 volt solenoid looks like. You'll see on the bottom it's got these 5 prongs and a very boxy shape. If we look at this diagram, this will explain to us what these things really do. So on the solenoid, or oh my goodness, on the relay, there's a solenoid inside, and that's going to swap which circuit is connected. So these 3 prongs that make a triangle, you have common, normally closed, and normally open. The normally open pin is not connected unless the solenoid connected by the gate pins is connected. So what that means is in the powered off state, this common pin is going to connect to the normally closed pin. So there'll be electrical continuity there. And when you add power across the gate, this common pin is going to connect to the normally open. If you wanted to represent that in like a circuit diagram, this is one of the symbols that you could use. Different people have different conventions, but this is the one that's pretty comfortable for me, so I'm going to use it on my diagrams. I've brought an example circuit to show you how this is going to work inside the actual Roomba itself. And the theory of operation is as follows. So when the Roomba is on and it is controlling itself with the native circuit board, we are not going to power the coil in the relay. This is going to be symbolized in our system by a green LED shining. So that's the normal state. When we energize the coil, it's going to swap the circuit and connect the actual motors on the Roomba to our controller, that rev control hub. And so when we see that in the circuit example, the light's going to turn red. So let's go on. Let's start. This is the example circuit. There are no microcontrollers in this circuit. It is just power and the relay. So when we turn it on, see the green LED kicks on. And if we ground this last jumper, if we complete the circuit by doing this, you'll hear a click, and that's the sound of the solenoid activating, and you'll see the LED turns red. So that would be what it looks like when we control the Roomba, and in its base state, it's just going to be green. So again, whenever you power the coil, boom, flips like that, and it'll connect through to our controls. So we can set this aside. That is all said and done now. And the actual circuit that we've got to make has a diagram that looks like this. So it's a little overwhelming, to be honest, but really it's 6 relays that are all connected to different ports, inputs and outputs, and ultimately we're going to have to handle these wires and get them connected nicely. So to help with that, we've got some already crimped and ready sort of twisty wire connectors. We've got soldering iron, and we've got the basis of this circuit. So this is a solder-based breadboard. These are 6 DC relays, and this is the connector that we're actually going to connect it to on the rev hub. We've got it wired up to this DuPont connector, just like a standard LED would be on the rev hub. So that way when we're ready to integrate it, it's just going to plug into that servo 0 slot, and that will be the way we control whether or not the Roomba is using its native circuit board or our circuit board to control it. On the back, you'll notice all these different traces. These horizontal ones are for the gate pins that I was talking about. These are what's going to activate the actual solenoid to make the relay swap between the normally closed and normally open. These tall, skinny traces, these are the ones that we're going to need to connect the motors to. And so if we look at our diagram, the way it's going to look is the output of this one is probably going to connect to the red wire on one of the drive motors, and the second relay is going to connect to the black wire on the other, or on the same drive motor. We'll have both of the red leads based on the Roomba circuit board and my circuit board sort of soldered right next to each other, and we'll just have to go down the line. So it might be a little painstaking. We are going to have 18 solder connections to make and 18 wires to connect. So we've got our work cut out for us, and we're good to go whenever we're ready to start. So for the first thing, we can go ahead and get these jumper connections soldered on first, and that's going to help us sort of get rid of some of the clutter, some of the options. That'll take away 6 leads that we have to worry about. And another good check to do, I actually had to do some work off camera because I messed this up the first time around, but it's always good when you're ready to finally start soldering things to the breadboard, you're thinking that you're done with the mechanical side, to go ahead and double check those coil resistances on all your motors. If you see a 0 ohm resistance everywhere, that's a huge clue that something got disconnected. I had to make some extra relief holes on the inside because when I closed it and I reassembled it, I accidentally crimped some of my wires and severed them. So that was super bad, had to undo it all. But let's go ahead, we're gonna go and check and make sure that all these coils have some resistance. So we're measuring, let's see if that's the drive motor. Yep, so that's saying about 10 ohms of resistance. Let's go to this next one and let's see. This should be the blower motor. Yeah, it's reading all over the place, but it's reading, so that's good. Let's get a better connection. 16 ohms on the blower motor. We check the other drive motor. 60 ohms, so that's very different from one drive motor. I'm interested to see if it's gonna turn out to be slower or faster, or how that's gonna manifest as a problem or not. And then the agitator is the carpet brush is 15 ohms. So if we add all those together, we could figure out how much power draw this total system is. Again, we would use that trick with Ohm's law where you take the voltage, the expected resistance, and figure out the expected current that coil resistance would create, and you can use that as a estimate for how safe or unsafe your system is going to be. So just keep that in mind. That's a good way to do it. One last thing I'd like to show, just to confirm that we know which coil is the normally closed one and which one isn't. I'm going to put the multimeter on the beeping setting and just touch these leads to show that the one that is like diagonal and down to the bottom left of this board over here, so from top right to bottom left, that is the common to the normally closed for each of these. So I can just go through, I can tap all of them, verify it before I get too excited, and there's good continuity, good contact all the way through. So now we're off to the races. We can start attaching these, and the way I want to do it is like so. So this is going to be the malicious control wire. This is going to be ours, and so we're going to connect it to the normally closed side. This is the one that did not beep when I just touched it with the multimeter. Getting messy. Alright, well, it's on. So that's the red wire for one motor. We're going to tack on the black wire for the same motor. for one of the drive motors. That was a much prettier job. I don't know why the last one was so bad, but let's see. Now we're gonna go red for another motor. There we go. Exquisitely done. Looks very neat. Let's go black for the next. There we go. So this is easy enough so far. And then we are going to get, these are also signal wires, but these share a common ground with the battery. And so we're going to use them differently. We're only going to worry about the red lead on these. And that's all captured in the circuit diagram too. There we go. And we got our last of these VH style wires to connect. The JST VH wires. And there we go. And so you see we're starting to build on the circuit board. This is what we got so far. And now a lot of it is going to be based on actually soldering the wires from the motors down onto this board. So we're gonna set it on top over here. I'm gonna keep this diagram handy in case I need to refer to it. Make sure my soldering there on top, my solder's nearby. Let's bring on down the camera. So this part is really where the magic happens. This is where everything's got to be pretty good or it'll be pretty bad. So you see this bundle of 4 wires is the motor, the actual drive motor connection here. So this one, this white wire is going to connect here. We have a red one down there. Actually, I don't know that I like the way I did this. And just while I'm here, just neaten it up a little bit. Get some wires to squish that. It just got a little wide. I was worried it was going to touch another contact, so. How I redid it, so okay, that feels a little better to me, ever so slightly. Now it feels much better. Okay. So there we go. So that's one. And then we're gonna get this white wire on like we said we were, like almost a minute ago. There we go. And then this blue wire is the black lead on the motor. There we go. Nice and painless there. And then these are the ones that are going to attach here. So these are the signal wires for the motor, and they're going to connect right on the opposite side of our signal wires. There we go. Getting a little toasty. There we go. And then this is the black lead, so it's going right over here. Alright, so that should be one motor fully wired up. Everything's good. Let's pull the other motor wire from the other side so we can just keep working one side to the next. I think that'll keep everything nice and neat. And so we're going to put the native wire here. Start melting. Oh, soldering iron turned off on me. I knew something was up. You can see we're going to have to bend this wire up and over and then solder it down like that. And then this one much the same. Gonna have to up, over, down onto that. So I'll have like that set up. And this probably coming from the outside. And this one is a little nasty. So now we'll see if we can get the red one on first. Just work completely left to right. That's pretty good. Happy with that. There we go. Let's see if we can get this one. There we go. And last one on the motor wires. Now, one of the problems I had, which is why I didn't finish recording the first time, was actually that the tip of my soldering iron got really nasty. And it made it a real pain to make these precise little connections. I got so frustrated I had to, take a step back from it. So I figured that wasn't a good representation of the process. It's better get clean soldering iron, right tool for the job. And as you look, we got these two hanging off still. And we only have 2 more bundles of wire. So for these, the way these get wired up, this black part is going into this connector that relates to that plug-in part, and this white wire is actually the native wire from the Roomba. I got the color scheme flips between the motors and the blower and the agitator, which is kind of sloppy, I will admit, not my greatest work, but at least I know, you know, like mentally, just in my head. Now, let's see, how are we gonna approach this? This is, if this flips over like that. It's just gonna end up looking messy. That's an oof, but it's not the end of the world. I was planning on it doing this and then going here. It's not terrible, but it's, I just want to make sure I'm getting the right spacing when everything's getting plugged in. These come on the inside. Yeah. All right. We keep on keeping on. That's down there. Also up there. Now we can get, so this white wire is the part that actually goes to the motor. That's the part that needs to get tacked on here. Go. And this one, make sure I'm not being a little careful. This one goes on here. Now we can pull out that corresponding plug and try to make sure everything's not like crisscrossing too much. So this one's going in there. You just slide it in. And this one, let's hang it out a little bit so we at least know what not to cross. So these wires are a mess, but they'll at least be not crisscross each other, so hopefully that'll save us a little bit of headache. Now I gotta go get this on. Alright, I think that one needs a little bit more solder. There we go. So that is actually it. That's all the wires soldered on. Well, now we just need to plug in the last wire. That's actually it. So we can get everything plugged in and we'll see how this actually ends up looking. So these are configuration. We're probably gonna have these go in like that. Make sure to give them a little tug. They feel pretty secure. This one will go in here and here. And so we should actually be able to give this a test. I'm going to get everything plugged in as if we're going to operate it, you know, run it, and then we plug the power cord in. And this looks pretty sketchy. Bunch of wires coming off. Got a control system on there. let's go ahead, flip it over, and get the last few mechanical things done on it. So the first thing is going to be putting in the battery, and then we put on the plate that squishes it into its actual position. And if we look, everything turns on. The room is a little confused. I think it still needs to do its like boot sequence, and then it's probably going to wonder why it's not on the dock. But it's making some nice chirping noises. Must not be too upset. Let's see if we get these screws in. Oh, it just tried to move. Heard it.
Error 6. Move Roomba to a new location. Then press clean to restart.
So it works well enough that it can give me an error message now. That's very promising. Let's go ahead and get this last little agitator plugged in. Now we're going to take it to the actual dock on the floor where it belongs. So let's see if everything's right. Oh, look at that. It did the auto dock thing. So if we just twist it, it works. It's a little confused, but oh, look at that. Let's see if it finds its way back on. And the cool part is we're using the actual battery on the Roomba. Oh, that is so good. All right. Well, that's it. That's the end of episode 5. I think the 5, 4, whichever it is. It might actually be 4. I think it's 4. So yeah, that's the end. And next episode we'll have it programmed running.